Okay, I'm gonna make a video here. I'm actually hoping to solicit people's input and response to it. I'm gonna try to keep it relatively short. The subject is climate change. So a couple years ago, and I think we've completely botched the message on this. I don't think climate change is about a model, what model assumptions are, what so-and-so said 20 years ago. It has nothing to do with that. The climate already changed, already happened. Changed a little bit, then it changed more. Now it's changing even more. How do I know that? A couple years ago, I did this same analysis and I was trying to avoid doing it all over again because I didn't want to spend the time, but I did it anyway. I couldn't help myself. And I'm just going to explain what I did. And I would encourage anybody that has any question about any of this to do the same thing because I'm not using any more over here in this spreadsheet than a high school kid could do. It's all in Excel. So I downloaded from NASA a data set. It's right there, the GB GLB TS plus DSST, which is sea surface temperatures. And I just downloaded the data. There's the data. That's the data only. There's transpose of the data. There's a transpose A. Like it's just data, just like it's just data, and it comes from a reputable source. And I'm going to show you before it's over. If you use different data, doesn't matter. The outcome's the exact same. And then I put the data in Excel, and I asked Excel, Mr. Excel, what is this value here? This first value, negative 0.17. Where is that on the bell curve of all the data? I'm just going to comment about probability. I understand not everybody knows anything about probability. In fairness, even though I have a bit of a background in mathematical physics, I didn't know much about it either until I got in the wind power business and everybody did their probability statistics wrong. And so that I actually ended up learning a lot about probability. But um, in the natural world, we just assume there's a bell curve, and the bell curve works really, really well in natural systems. And it doesn't really matter if this bell curve is perfect. It's kind of the standard way to analyze something like this, and it comes up in this case with I think a valid outcome. Otherwise, I wouldn't use it. I'd go through the trouble of finding some other curve. Because there's more curves than just the normal distribution, right? So we take the data and we say, okay, Excel, what is the mean of this data? Mean is just the average. Well, the average is 0.074. So it's just the average. It's just all the data divided by the number of data points, 145. Boom, the data. And what's standard deviation? Well, that's 0.391. That's how much the data, the average piece of data is different, is wider, how wide this bell curve is. So if the standard deviation is a lot, the bell curve is really wide. And if it's not, if it's very, very small, it's very narrow, right? So, but it just is what it is. It's a number. You can see SD right there. It is in Excel. And if we were to plot this, it would just be, the hypothetical, the expected result is just would be this normal distribution, but actually not what we find. Put the data in. And you can see, well, the first year was about 73% expected, and the second year about 66% expected. So then, this is the data. JD means January through December. Just kind of the year is obviously the year, and the number is just the number of years. So the first year all the way to the 145th year. The Z-score is just what percentage of a standard deviation is that? So this is like half a standard deviation. That's perfectly okay, perfectly good number. 73%. Some of these years were 86%. I mean, all these numbers are right in what you would expect to find. you know, 90%, you know, that is that 90, in this case, like 90% of the years would be that number, or in this case lower. Um, it's all kind of greenish there for a long time. And then something happens. So we've been pumping CO2 in the air all this time, and you see the numbers start getting a little less well behaved. Well, 1978 was the last normally, so 50% expected year. So that would be the average year, the 50% year. If there's 100 years, that would have been the definition of the average right there. We had it 1978. Well, you know what? We haven't had an average year since. And every year since then has been less than average. And this kind of gets to my point about people who don't fully accept this climate change thing. You go back as recently as 2020, and we were still on that bell curve. Like, I mean, like that year, 20.9%. I mean, that's not unlikely. That's going to happen 20 times out of 100. I mean, so we kind of like we kind of jump off, we kind of jump off into the deep end in 20 in the year 2000, not really, but the year 25, you know, 2005, we definitely do. And just go think back what I mean, I think back what I was doing in 20, you know, in 2005. And uh you know, I was in this industry at the time, and I said to people, whatever you do, don't justify renewable energy with climate change, because this data is inconclusive. People might remember saying that. Now, here I am 20 years later. I'm not saying that at all. I'm saying, oh shit, I can't even believe this data. So, of all the people in America who are surprised that this data is coming out the way it is, I'm one of them. But I'm not I'm not denying what I'm seeing either. And what I'm seeing is like conclusive and alarming. So now just come back down and you look at 2015. The 2015 is an interesting year because it's one of those IPCC report years. Everybody says, "Well, I don't like the IPCC." I don't like it either. And I never believed in that crap, and I still don't. So I'm not saying you got to go nuts on all these people from all over the world getting into a room and coming up with like some outcome that we all should just snap to and salute to. I don't. I like it. It is a very political process, and it results into all sort of idiosyncrasies. So if you know anything about it, you can cut it to shreds, which is exactly what the people who want to discredit the process do. And it's it's pretty easy work for them, actually. So one of these years, that was an the AR5 year. And so people say, I don't believe AR5. And I don't know if I believe it either. Like, look, the data, it wasn't conclusive then. But man, the last 10 years have been ridiculous. It's the knockout punch, guys. Knockout punch. Last year, the hottest year in record, 3 standard deviations away from the normal. In other words, it was a year that should not have been possible. It's not just summer. It's not just the weather. It's not just, oh, this is natural. No, it's like we're off the chart here. The year before was 0.05. And I always wondered, because some of these years there was a big, strong El Nino, which meant it was there was a big, strong La Nina, which meant it was colder than it otherwise would have been. And I'm like, what's going to happen when that La Nina goes away? Well, what we know, it was really ugly. And here we are in 2005. the El Nino's gone away. We're in kind of a neutral year. We should be having back to an average, whatever the new average is. And I'm telling you, we're not. It's going to be the second hottest year on record again, or maybe the third, but it's going to be one of these P99 point something years. So just like humor me for a minute and say, okay, what's the joint probability? What's the probability of having a P98 year followed by P99 followed by a P, these probability years? Like, what's the probability of having them all in a row? And the answer is 0. So, I mean, if you want to get, the answer is 1,000 times, 1,000 times a billion times a billion. That's 0. So, it's more likely to win the lottery twice in a row. And you still won't get to this probability. And I don't think people are using playing the lottery as their base case business plan for their lives planning. I hope they're not. So this is this data. So I'm like, okay, I'm going to plot this. So then I use Excel to plot it. You see, it's not exactly linear. See, if it was linear, that is not a straight line. Otherwise, that line would be straight. That's the full data set. So then I go, well, was the first 100 years pretty linear? And the answer is, yeah, he was kind of. The last 45 years, yeah, no, we went straight up. And you'll notice that this slope of that curve, as they say in the math department, is higher than the slope of that curve. So in other words, we are increasing our rate of temperature change more rapidly than we were for the first 100 years and the second 45 years. And then I did something that the high school kid probably can't do, is put all this data in MATLAB. And what did I find when I did that? I found we're screwed. So what I found in MATLAB was this is the linear fit, if you will. Doesn't really fit very well. This is the linear fit with the exceedances for the average year. You just see we're kind of off the chart here. But then I asked MATLAB to do something else. I'm like, okay, I'm going to go into some app. I'm going to go curve the fit. Yeah, the program's going to take a long time, but I'm going to cheat. I wanted to do it live for you, but not if it takes forever. I got the curve fitter coming over here. Like, it's just going to take forever. I'm not going to do it. Okay, so I'm going to select the data. Okay, I don't want that data. Like, I gotta go. I want the JD. JD stands for January, December. So in other words, the annual. So the X data, no, I don't want the, I don't. I want that. I want this to be N. I want this to be JD. I close it. Boom, there you go. There's the data. And so if I just do a linear fit, that's what I get. And the R squared is 0.76. I wasn't going to lie to you. I remember pretty good. It's a pretty good fit, but you can see what I'm talking about. You've got really 3 different pieces of data. There's data that's kind of going like that. This piece of data that's going like that in the last couple of years, which are just going rocket right to the moon. And so, okay, I know this is kind of like in the math department stuff, but we can just do a different fit, and this one fits to a value of our wow uh yeah, R squared of 91. I thought it was 90. It should be. We need to make this little pi square robustness, and yeah, there we. That's still. I mean, it's a good fit. I got it to Pete. I got it to 92%. I mean, a 92 coefficient fit is a very good fit. Well, this is bad news because, like, guys, we're just like on the train. Oh, the train sped up. I'm going to get to the station sooner. Oh, the train is going off the cliff and we're going to crash. Like this number going up to the end of the century, for example, gives us gives us probably 5 degrees of temperature rise from the pre-industrial period, which is in the category of we're screwed. So my point of this analysis is, and then I took the bait, and the government came out with something that, and they invited public comment on it. I'm like, okay, I'll do it. I didn't think it was going to take me all this time, but I'm like, okay, those are my results. What are other people saying? Well, sure enough, I go look at Hawkins 2025, the climate stripes, blue, 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 red, red, red. The same thing. He's saying the same thing that I'm saying. This is over the last 2,000 years. So no, like this isn't just weather, guys. Like this is like a not just weather event. And I could go back. This is the last 2,000 years blown up. I could go back to look at the last 800,000 years. It'd be equally as alarming. And then, they have other charts that go back further. There's no good news. There's no good news in the, going back to the dinosaurs. Dinosaurs don't have a lot of good things to say. Then this other guy, Foster, said, because I didn't remove the second order impacts. So you've got the big one, which is the CO2, you got the data. But people who do this for a living adjust that data for the variability of the El Nino La Nina cycle, for volcanoes, for sun irradiance. The sun's not the same brightness every year. Um, and they came to the same number. So instead of thinking we're at 0.2 degrees C per decade, which we would have thought like 10 years ago, no, we're at 0.04 degrees Celsius per decade. So when you see some of these guys show up and say, oh, what are you talking about? It's only 0.2 per decade. Why are we worried about it? Well, no, it's actually not. It's 0.4, and that's going up. So anyway, Foster kind of agreed with me, and they did the adjustments. The State of the Climate report was published in BAM, the uh, Bulletin of American Meteorologists, and said the same thing. We've got our CO2 is up to 422. Ridiculous number. And they say, they come right out and say it, that we're at an Earth that's hotter than it's ever been in 125,000 years. So I don't know about you, but I don't think we had much of an economy 125,000 years ago. And so we always are like, oh, could a man survive? Yeah, a man and a woman could survive in a very hot world somewhere. But could this world support 6 billion people in the economy? No, absolutely not. So um, now I'm going to just go. This is kind of interesting. So I don't know if anybody has any doubts after this. 2020 23, 24, knockout punch. Um, so it doesn't matter what the sensitivity is to the doubling of CO2 anymore, or was this model, did the models predict? I read this Department of Energy report, and I can't go into all the detail, take me hours to go through the whole thing, but the guy says, oh, well, the models were the historical models weren't accurate. Go look at Haushofer 2019. Well, I remember reading Haushofer 2019 and 2019. And I'm like, oh, this is very good news. The guy just corroborated all these historical models were more or less accurate. Well, sure enough, he did. Like, I don't know, like I have it up here. And so what did Haushofer actually say? I'm sure he said he was quoted as saying in the report. I don't think the guy lied and just changed his words, but he left the conclusion off. And the conclusion was, we find the climate models published over the last 5 decades were skillful in predicting the subsequent global mean surface temperature changes, with most models examined showing warming consistent with observations, particularly when the mismatches, whatever. Now, I would say since this time, we've then had 5 super hot, crazy hot years. So if someone says, oh, the models were running a little hot, well, number one, some were and some weren't. On average, they were running pretty good. And secondly, now it's hotter. It's hotter now. So if they were running hot, you go put the last 5 years in, they're not running hot. Then I hear, oh, well, there's uncertainty about this doubling of, sensitivity. We double the CO2. How much is the world change? Well, go look at these numbers. Our experience is that number is probably higher, worse than that were in the models. So I do think this is important. I think the message is not about a model or the people like Hansen, who's the first guy who showed up in the 80s to talk about this, or could you sit there with the IPCC reports and models and just poke fun of them all day long? You could. It's a lot of fun. They're not. They are the product of groupthink. They speak in the language of scientific wokeness. That's not the point. The point is, this is the point. The climate changed. Like, there's no ambiguity to that chart. Zero. And I just did that. I mean, in fairness, it probably took me an hour. And the spreadsheet probably took me a couple hours, because I'm missing a bunch of rows here that I hid. I'll unhide them just so you know. I mean, I tried to figure out what was going on a kind of a rolling 10 and 5-year basis. And what I found was what I just told you, that there are these 3 periods. The period around here, which is fine, first 100 years. Then we went up 40 years, and the last 5 years, we're just going straight up and right where we don't want to be. So we got to change this conversation about climate change from models. We're never going to get anywhere when we're talking about models. We have to talk about it as winning the lottery twice in a row. We have to find some other vernacular where we can get the message across. And we certainly can't ignore people who are skeptics right now. They're not bad people. If you looked at this thing in the year 2000, 25 years ago, I'd probably still be a skeptic myself. So please get me your feedback. I'll post all this stuff on my own webpage, and I do want some feedback. Thank you.